B equal to C. That follows by necessity, right? You can draw yourself the picture. So geometric reasoning is also deductive, okay? All right. Okay, so now we're going to add to our list of inductive arguments, okay? Mathematical arguments are deductive, but this is not to be confused with statistical or probabilistic reasoning. Arguments based on statistical or probabilistic reasoning are not deductive arguments, they are inductive arguments. For example, considering the following. There's only a 10% chance of rain tomorrow, therefore it will not rain tomorrow.
I think that's what I'm trying to get at.
Yeah. Is that a guarantee? No. Right? So it's going to be inductive. And the odds of flipping heads on a fair coin 10 times in a row are just 1/2 to the 10th. Therefore, Steve will not flip heads 10 times in a row on this fair coin. Also inductive, right? Chances are he's not going to, but he could. Okay, so inductive. Probability, statistics. Okay, so one common mistake is for students to see numbers in an argument and say, math, right? Deductive, you gotta ask, what are those numbers doing before you can say math or statistics probability. Everybody got that, okay? And we'll have the chance to practice when we go over things, okay? How did I get to the wrong page? Okay, just got confused for a moment. And we already did an analogy, so let's get that. Okay, predictions are also inductive arguments, okay? Predictions, okay? And now, I'm going to be very particular about the way that I use this word. So let me tell you how I use this word so you don't label something as a prediction that I would say is not technically a prediction. First, let me give you an example of an argument based on predictions. Every Monday night during football season, Brian has ordered a pizza for delivery. Tonight is a Monday night during football season, therefore Brian will order a pizza for delivery. Can we be sure of that? No, he might be out of money or something like that, right? Or might be feeling sick and not hungry, so it's inductive. It's prediction. And here's how I'm going to use the word in a very specific way. Predictions are claims about the future. They're always claims about the future. Does everybody understand that? So if it's not a claim about the future, you might say, oh, he's predicting something. Ask yourself, is he saying that something will become true that is not true now? So for example, let me read this. To be clear, the term prediction is used in a very, very particular fashion herein. For our purposes, predictions are claims about future events. In this case, the following sentence is nonsensical. Based on the evidence, it can be predicted that it was Bob who stole the cookies. We're talking about an event in the past. Does everybody understand that? So we can't, what? It's not a prediction. Does everybody understand that? Okay. In the way that I'm using prediction. Okay. All right, so we got predictions. And next up is cause and effect reasoning. Okay, and cause and effect reasoning can go from the cause to the effect, but you can also reason backwards. You can say, I see this effect, therefore such and such must have been its cause. Does everybody understand that? Okay. So let me read you an example. Suppose I say, eating pizza causes Brian to have heartburn. Brian has heartburn, therefore Brian must have eaten a pizza. Okay, that's cause and effect reasoning, but which way is it going? Cause to effect or effect back to cause? Effect back to cause, okay? So now, this is one of the things I'm going to say, is there is overlap between predictions and cause and effect reasoning, partial overlap. When you're making a prediction, you're in some sense arguing from a cause to an effect. Does everybody understand that? Okay? So you might label something as prediction, and I'll say yeah, and you might label the same argument cause and effect reasoning, and I'll take either of those answers. Does everybody understand that? But if it's effect back to cause, we're not going forward in time, so it can't be a prediction. Does everybody understand that? So if it's a prediction, you can say prediction or cause and effect reasoning. But if it's going from effect back to cause, you have to say cause and effect reasoning. Does everybody understand that? Okay. All right. Okay. Now, going from the effect back to the cause is also known as abductive reasoning or inference to the best explanation, okay? Now, you could devote a whole entire class to figuring out how you decide what is the best explanation for any given claim, right? What's the best inference to the best explanation? So we're not going to do that, but know that you could go down the rabbit hole big time, okay, when you're going from an effect back to its cause, okay. All right, so another argument. Arguments based on authority. Okay, these are inductive arguments, okay? When we make claims such as Neil Armstrong was the first man to step foot on the moon, or the atomic weight of gold is 196.96655 grams per mole, these claims are usually based on an appeal to some sort of authority, the authority of a teacher, reference material, or a web page, for example, okay? But these things could be mistaken. Consider this argument. Miss Smith says that Neil Armstrong was the first person to set foot on the moon. Miss Smith is a history teacher, so that's establishing that she's some kind of an expert, right? Therefore, Neil Armstrong must have been the first man to set foot on the moon, okay? Are authorities always right? No, they can be mistaken. They can make mistakes, right? You might even see the atomic weight of an element on a periodic table, and they might have a misprint and it not be right. Does everybody understand that? So authorities are good reasons for believing things, but they're not what? They're not proof, and that's why they're inductive. Okay? All right. So we got that. Okay. So now I have a question for you, and that is this. Science. Wait, is that I for E or E? I'm dyslexic. Someone help me.
SCI. You have it right.
Okay. Science. Inductive or deductive? Deductive. Inductive or deductive? We'd like to think of science as, establishing things as true, right? But is it deductive? I'm gonna say, depends. Depends on what you're doing. Science can be either inductive or deductive, okay? And so let me explain the difference. When we're establishing a scientific law, it's inductive. When we're using the law, it's deductive. Okay, so for example, I'm looking at argument 20. Gas 1 was observed to behave in accordance with the following formula, P equals nRT. Gas 2 is observed to behave in accordance with the following formula, P equals nRT. Gas 3, same thing. Therefore, it is certain that all gases behave according to the following formula, P equals nRT. We can say it's certain that they do, but look, this is just what? Inductive reasoning, okay? So we're going to say inductive to a scientific law is inductive, okay? But from a scientific law is, we're going to consider deductive. Now, this is a little bit strange because we're establishing a scientific law via induction, which means a scientific law isn't necessarily absolutely true. Does everybody understand that? In science, over time, they'll say such and such is true, and then 200 years later they'll say, oh, that's not quite right, and then they'll amend it. But in the meantime, they took those laws as true. Okay, so we're going to assume that a scientific law that's been well established by induction and testing to be true, and so then if we use that law, assuming that it's true, to make some conclusion based on it, that would be a deductive argument. Okay, so everybody, are you familiar with the ideal gas law? Pressure times volume equals blah 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 blah. Okay, so we're assuming that it's true. We proved it inductively. So suppose I blow up a balloon and then I put it in the freezer for an hour. What's going to happen?